All right. Hi, Honors Pre-Calc people. This is the week after spring break. I'm recording this on Monday, April 13th. And this is the second video of this week. Miss Mitchell did the basic review of all things derivatives. So today we are going to start ahead on finding the derivatives of our two main trig functions. This is only sine and cosine. So first of all, let's show you how incredibly easy this one is. We kind of already know this, is that the derivative of sine is just cosine, right? So every time they say take the derivative of sine, it just turns into cosine. The other one is, what is the derivative of cosine? So what I want you to notice about cosine is when you take the derivative of cosine, there's actually a sign change that happens there too. It's a negative sign of x. And it really is that easy. You just memorize it. Okay, now we're going to show you some background for it, but seriously, this is it. You just have to know that these two work this way, that the derivative of sine is cosine and the derivative of cosine is negative sine. And then keep in mind that when we go backwards and we do the antiderivative, we'll have to remember to do these sign changes kind of in reverse a little bit too. So here's the main idea behind it. And again, this is just for people who really want to understand why it works this way. If you're not that, then just avoid it until you see me start writing on example 1 and pick back up with me then. Okay, for those of you who care about where this comes from, let's go and take a look at our unit circle again and identify our key points. So remember, this is one of our easy points to identify. It's 1, 0. This one up here is 0, 1. This one over here is -1, 0, and then this one right here is 0, -1. So remember that the first one is always cosine and that the second one is always sine. So if I was going to draw a sine graph on the x and y axis instead of around the unit circle, sine would be always the y value first, right? So if I were going to go and draw these 4 places, so 1, 2, 3, 4, and these would be called 0, then pi over 2, then pi, then 3 pi over 2, and then 2 pi. We're saying sine would start at 0, then at pi over 2, that's our angle, sine would be 1. Then by pi over here, it would be back to 0. Then by down here, it would be -1. And then by 2 pi, we'd be back over here to 0 again. So it'd make this nice little wavy pattern. All right, so that's our sine curve. And you're like, great, what does that have to do with derivatives? Okay, so if this is our sine curve, remember that derivatives is always looking at the slope of a function, right? So what does the slope look like when I look at this function of sine? So the slope looks like it is positive here, it's going uphill, then it's 0 at the top, then it's going downhill, so it's negative here and here, then 0 at the bottom, and then it goes back to positive. And it's a cycle, so it just keeps doing this wave pattern of going uphill, hitting a plateau called a 0 slope, and then coming back downhill, and then going back uphill. So it would make sense that when we say what's the derivative of sine, that it turns out to be positive to start out with, because we're going uphill in the very beginning. We could also look at the unit circle directly and just follow what happens to the y's. We go from 0 to 1, so that means in between here the slope is positive because we're going uphill. We're going from 0 to 1. From 1 to 0, we're going downhill, so the slope here would be negative. And then from here to here, it is still negative. We're going from 0 to -1. And then from -1 to 0, we're going to positive. So where was those slopes ending up being 0? Well, they happened when we switched signs, right? So when we went from negative to positive, right here is the exact same spot as 3 pi over 2. We said there was a 0 slope there as well, okay? And I'm going to do the same thing with cosine. I'm going to spread it out and do one horizontally instead. So here is my cosine of x graph. We have 4 sections around the unit circle. So 2 pi is here, pi is here. We have a 1 and we have a -1. So on cosine, we're going to be looking at the x of the unit circle. So we're going to start at 1. And then by the time we hit here, we're going to go down to 0. By the time we hit over here, cosine, which is the first letter or the first variable, is going to be down at -1, then 0, then up at +1. So this one also is the same wave pattern, except it just hits its lows and its highs in different places. So in the same way, we can look at what the slopes are on this blue curve. So we can see that when it starts, it ends up going downhill first. Then it hits a 0 slope down here. Then we go uphill again, because remember, derivative is just what the slope looks like. So when I take the derivative of cosine, I start out going downhill first. That's why it's got a negative in the front of that one. And again, if I just look at this one looking around the unit circle, I can see that as it goes from 1 to 0, it was going downhill. Then from 0 to -1, it was still going downhill. So those are those first 2 dots on our graph over here, right? And then after that, we go from -1 to 0. So it starts going uphill in this section. And then from 0 to 1, it goes uphill in this section. So we can see that it switches right here at 3 pi over 2. And then also at the very beginning, there's a slope of 0 right there. All right, so that's our main overview idea of this. Overall, what you have to know is just that the derivative of sine is cosine, and the derivative of cosine is sine, but you have to do a sign change to it, so it's got a negative in front of it. All right, so let's go use those. A few of them are going to start out nice and easy, and then we're going to go into some product, quotient rule, and chain rule stuff. Okay, so in our first one, it's just a 7 is a constant, so I just say the derivative of y equals is just going to be the 7 carries along, and this is cosine of x. Remember that the derivative of sine is just regular. Cosine is always the weird one, okay? All right, over here, I'm going to have to do a chain rule because it's not just sine of x, okay? So I'm going to start out with what's the derivative of sine is cosine. Don't change anything else. So I just did derivative of sine. And then I'm going to multiply by the derivative of the inside thing. So the derivative of 7x is 7. So we get that the derivative of this one is, there we go, is going to be 7 cosine 7x, right? So we don't multiply stuff into that angle after the word cosine. It just goes to the front, all right? All right, next couple. Okay, so next one I'm going to rewrite so I can see that it's a 1/2. You don't have to. You can go the other way if you want to, but I like going this way. So this is going to be, let's see, it's going to be sine of x to the 1/2 power. So the derivative is going to be take care of the power first, which means I'm going to have a 1/2 and it's going to be raised to the -1/2. And then what's inside the parentheses is going to stay the same, but we're going to get a chain rule. So the first thing I did is I took the derivative based on the 1/2 power. Okay, and then I kept this the same. Now I want to do the derivative of sine, which is cosine of x. So when I put this all together, it looks like I'm going to have a 2 with the square root of sine x at the bottom. And on the top, I'm just going to have a cosine of x. Okay, all right, next one over. This one I'm going to rewrite because that 4 has been getting a lot of us very often that you don't know that it is just this, right? That it's just a way for them to not have to write the parentheses. Okay, so if I put this into derivative format, first thing I'm going to do is I'm going to take care of that 4 power. So it's going to be 4 lowered to a 3rd power. And then I'm going to multiply by the derivative of the inside, which is negative sine. So when I put all the stuff together, all the coefficients in front, I've got a 4 in front and I've got a negative, so that's a -4. And then I have cosine of x that's cubed and a sine of x. And remember, I've already moved the negative to the front, so that one's done as well. Okay. All right, moving right along. Okay, so here is an e derivative. So remember the format for e derivatives is you start out by repeating what you have, and then you multiply by the next thing, which would be the derivative of the e power. So the derivative of cosine next. So I did the derivative of e is just repeat e, and then I'm chain ruling it. So next thing is what's the derivative of cosine is negative sine. Okay, and then I still have the stuff on the inside, which is 3x, so one last chain rule of 3. Okay. All right, so putting all those together, it looks like I have a leading coefficient of a -1 and a 3. So I'll put the -3 in front, and then I can either repeat the e first or the sine. It doesn't really matter. So e to the cosine of 3x times a regular line sine of 3x. Okay, so that had a chain rule that had 2 additional chains on top of the first one. All right, our next one is going to be, same deal, we're going to have a chain rule here. We have an ln and then we have a cosine. So this one just has 2 chains to it. So the derivative of an ln is always 1 over the stuff times the derivative of the stuff. So the derivative of the stuff would be sine with a negative sign in front of it. So that would be negative sine of x over cosine of x. And you could leave it like that, or you could show yourself to be super smart and say, I know sine over cosine happens to be tangent of x. And that would be all good. All right, so there's our first page. Okay, so main idea, derivative of sine is just cosine. Derivative of cosine is sine, but you have to do a sign chain in front, so a negative in front. All right, so our next two, let's see, looking at example number 7, I can see that there are two x's that are going to be divided by each other. So this is going to be quotient rule. So remember, quotient rule is derivative of the first thing times the second thing minus keep the first thing, derivative of the second thing, all over the second thing squared. So our first thing is cosine of x. Its derivative is negative sine of x. The other thing is e to the x, and yay, the derivative of that one, my favorite one, is still e to the x. Okay, putting them into the formula for quotient rule, we're going to start out with negative sine of x times e to the x minus, and then do the other version is going to be cosine of x times e to the x all over e to the x, the quantity squared. Okay, and that's technically done, but I can see some simplifying there. I can see that there's e to the x's on the top that I can factor out, so I'm going to go ahead and do that. So if I factor out an e to the x on the top, I'm going to get negative sine of x minus cosine of x. And on the bottom, I actually have e to the x times another e to the x. That's what squared means, right? So I could cancel those out and just have negative sine of x minus cosine of x all over e to the x. Good. All right, on to the next one. So again, I'm going to rewrite this one. So I'm going to call it cosine of x, the whole quantity squared, minus sine of x, the whole quantity squared. So when I go to do derivative, this is just going to be one chain rule. Let me move that down a little bit for you. Okay. All right, so first thing is bring the 2 in front, lower the power to 1. Okay, inside stays the same, and then on the outside you multiply by the derivative, right? Okay, and then I have a minus sign. And then I do it again with the 2, lowers down to a 1, and then I have to remember to chain rule it times cosine of x times the derivative. Okay, putting all these together, they look like they might actually go together. I don't know whether they cancel out or double up, so I'm going to look at coefficients first. I see a 2 times a negative, so that's negative 2, and then I'm going to decide that I'm always going to write cosine first in this example just because it showed up first. Then over here, coefficients, I've just got the negative 2 in front. And then I've got, again, in the same order, cosine and then a sine. So it looks to me like before the minus sign, there's negative 2 of them, and then there's another negative 2. So these are not going to cancel out. They're going to double up. I'm going to have negative 4 of them, of cosine x, sine of x. All right, so there we go, using derivatives for sine and cosine. All right, so just because we're reviewing here, we're going to throw in some old stuff that we used to do as well. So on this one, remember, if they say horizontal tangent, what do they really mean? They really mean is they want me to go find when is the slope equal to 0 and tell them what x equals, right? If they want a horizontal tangent, that means that the slope is going to be equal to 0. Okay, so I need to get to slope. So I'm going to take the derivative of y equals cosine of x. So that's going to be derivative is negative sine of x. And then I'm going to set the slope equal to 0. All right, so they are asking me where is sine equal to 0, because I could divide both sides by negative 1. So they're asking me when is sine of x equal to 0. All right, I know that's going to happen on one of the 4 places. So remember, this is 1, 0. Is which one of those numbers is sine? Remember, this one's cosine, this one's sine. So this would be one of the places I would want. So I could say x equals 0 pi or 0 degrees, but I know they want radians because they put in 0 to 2 pi, which is radians for sure. Okay, so then let's see what else we can find out here. All right, so this spot right here is 0, 1. That is not where sine is 0. That's where cosine is 0. Over here we have negative 1, 0. That does work, so I would call that pi. This one would be 0, negative 1. That does not work because the 0 is in the cosine spot, not the sine spot. And they say go around until 2 pi, but notice there's no equals under the 2 pi, so I'm supposed to stop before I hit the next one, which would have been 2 pi. So there is my answer. Okay. All right, and then let's do one more like that, and then I think we are done. So let's take a look at this one. It says using y equals sine of x, horizontal tangent, okay, has a horizontal tangent with a slope Okay, now those two things do not go together, people. Somebody made a mistake somewhere here, and I am not claiming this one. Okay, it can't have a horizontal slope and have a slope equal to 1/2. Okay, so it's got to just have a tangent line that has a slope of 1/2. Let's do that version. Okay, so it's going to work very similar to the other one in that I need to find the slope, but this time I'm going to set the slope equal to 1/2 and solve it. Okay, all right, so y equals cosine of x is the derivative of sine of x, and we're going to set this equal to 1/2. So now we're asking, where is cosine of x equal to 1/2? So this is kind of like our inverse problems, but in our inverse problems, in our arctangent or arcsine problems and inverse cosine problems, remember that we could only give one correct answer. This one doesn't have inverse anywhere around it. So I'm going to give every possible time that it happens between 0 and 2 pi. So my first question is, when is cosine going to be positive? So all students take calculus. Do we agree it's only going to happen in quadrant 1 and quadrant 4? All right, next thing I need to do is I need to go look at my chart or recreate my chart about what are all the angles. So I have 0, I have pi over 6, I have pi over 4, I have pi over 3, I have pi over 2. Okay, so if I'm doing sine, remember that if I started at here, it was 1, 0. So sine starts at 0 and goes uphill. Radical 2 over 2, radical 3 over 2, and then radical 4 over 2, which is just 1. Okay, that is not cosine, so I have to go to do the next one. So in cosine, it reverses. We start at 1 and we go radical 3 over 2, radical 2 over 2, 1/2. This is the one I want. Okay, so that means that my angle that goes with it is pi over 3. That means that I'm looking for a reference angle of pi over 3 in quadrants 1 and 4. So back to my picture, here's a quadrant 1. This angle right here is pi over 3. This angle right here is pi over 3. But if I just said pi over 3 twice, you wouldn't get the answer in fourth quadrant. So first quadrant answer is pi over 3. Let's go around and count up by thirds. Okay, so this was 1/3. By the time I get over to here, it's 3/3 pi, right? That's where 1 pi belongs. So it's from 0 pi to 3 over 3 pi. And then to get back around here to this way, to get all the way back to here is going to be 6 pi over 3. But I didn't go that far. I stopped 1/3 beforehand. Okay, so that's going to be 5 pi over 3 are going to be my two answers between 0 and 2 pi. Okay, that one was a little bit more challenging. Okay, so let's say that we were doing one, just so that, because I feel like people are going to struggle with this part a little bit. Let's say that for whatever I was doing, we're not going to worry about whether it's derivative of sine or cosine this time. Let's just say that you were looking at an answer that was in quadrant 1 and quadrant 3, and your reference angle turned out to be pi over 4. Okay, so I know I'm going to have one here, I know I'm going to have one here. I know it starts out at 0/4, right? So if this is a distance of pi over 4, right, pi over 4 would be one of my first answers. Okay, then by the time I got over here, I would be at 4 pi over 4, and I would keep going past that another 1/4 pi. So the other answer would be 5 pi over 4. So you're always either adding to or subtracting from the horizontal line. That way you're not trying to work with 90-degree angles, because if we're doing a third, 90 degrees and thirds don't go very nicely together. So using the horizontals makes that easier to count with. Okay, so let's try one more of those just to make sure we're okay. Let's say that I had an answer that was in quadrant 3 and quadrant 4, and that the reference angle was pi over 6. Okay, so quadrants 3 and 4 are here and here. They're saying the reference angle is pi over 6. Reference angles are always to the x-axis. So if I started at 0, 6, I wouldn't find a single one by the time I reach 6, 6. There's not a single answer in quadrants 1 and 2. But then if I go one more 6, I found this one. So this answer would start out with 7 pi over 6. And then the next one would be almost as if I went all the way around. So 12 over 6 is 2. But I stopped right before I got there. I stopped 1/6 before, so that is 11/6 with a pi. Does that kind of make sense? So once you know what your referencing angle is off that chart, you want to make sure when you're giving it from 0 to 2 pi that you're moving around the unit circle from quadrant 1, 2, 3, and 4, and you're always either adding to a horizontal or you're subtracting from. So this last example, we had one of each. All right. All right, so there's going to be a worksheet that goes with this homework as well. And again, remember that Powers people, we do a video chat on Thursdays to go over any questions you have. So it's always a good idea if you have questions, put them in the Google Classroom comments so that all of us know what you're struggling with, so we know what we need to address when we see you guys again next time. All right, welcome back to school, you guys. We'll talk to you later.